Hello, everyone. Today is August 19th. This is the core platform lunch and learn session for August. I'll do this lunch and learn. The topic for today is Prometheus from QL and Mimir and how we use it at GitLab. I do have a set of slides prepared, but I want this to try and be interactive as possible. So feel free to interrupt me at any time if you want to get more information about a specific topic. We can. Um, I focused mostly on PromQL and how to use it. So if you have any queries that, I don't know, you're curious how they work, or you wanted to get some information from Prometheus before but couldn't, we can try and do that together as well. So um, yeah, I'll get started unless anyone has any questions or suggestions so far. Sweet. Okay. So, yeah. So what we'll cover is what is Prometheus, the data types around Prometheus, meaning what kind of metrics we can store from QL, how we can query those metrics, and we'll do some demo sessions around that. And then how we run it all on GitLab.com. Because on GitLab.com, it's not just simply a Prometheus server running. So what is Prometheus? It's an open source monitoring tool. I'll mention this because Matthias is in the call. It was created by SoundCloud and open source later on. It focuses on metrics on the application. And by metrics, we mean things that we observe around the application. For example, the latency on the request, how many cache hits we're getting on a specific path, for example. Anything that you want to observe, you can expose it as a metric. Stores everything into a time series database because we look at these metrics at a very specific interval and we create a time series data out of those metrics. And Prometheus also provides rich client libraries. So for example, if you're using Go or Ruby, you pull in a gem or a package and you can expose custom metrics for your application, which is fairly straightforward to do so. So this is a high overview of the architecture for Prometheus. It seems overwhelming, but it's not very much. So you have the Prometheus server, which is written in Go. So it's a single binary that you plop into a server and execute it. And it has three main components inside of that server. It has the retrieval service, which basically it will reach out to what it calls the Prometheus targets. So in our case, it's going to be the application. Imagine Suct or the Rails application. It will send a request to those targets, get the metrics, and stores them in the TSDB, which is the time series database, which end up being stored on disk. And then the HTTP server, which is basically exposing the data that it scrapes from the targets through Grafana or Prometheus Web UI, or even the API if you care. And it also ends up sending requests to another component called Alert Manager, which is probably the component I hate most when I'm on call, because this is the service that ends up paging me from time to time. And basically, it reaches out to PagerDuty or email or Slack or whatever you want to set up your notifications like. So I mentioned the Prometheus targets here. You can hard code these targets, or you can use service discovery. So it tries to discover the services out of the box. I'll go a bit more into detail how that works. So by default, or the most common way, is to scrape your targets every 15 seconds. So by scraping, I mean Prometheus will reach out to the endpoint. So here I'm doing a demo of /metrics. It will look at all these metrics and store them in the TSDB. And you can see the metrics here are just pure text Like it's not JSON or gRPC. It's nothing fancy. It's very, very simple. It's just text being returned in that endpoint. And you can define the targets in the Prometheus.yaml file, which is the configuration file for Prometheus. Now, diving a bit deeper into how the metrics look like. So you have the name of the metric, and then you have what Prometheus calls labels. So this is, if you want to think about it like Postgres, you have a row, and the labels are the columns, right? The columns are any specific value that you want to define. So these can be engineer defined, basically. By engineer, I mean the developer defined. Just be careful when you add labels like this. The higher the cardinality, the worse Prometheus is going to perform. So don't put in like user IDs or IP addresses or something like that. Try and keep it as limited as possible. So, for example, 10 values for each label and so on and so forth, because they multiply. So in this example, this metric only has one label, but if it has two labels, it's not just four possibilities, it's eight possibilities, and so on and so forth. So it really, the more labels you add, the more values those labels have, the bigger the cardinality. So it gets a little bit, it explodes quite considerably. So what can Prometheus scrape? Anything that you kind of talked over HTTP. So the most common way is your application has a / metrics, and it will expose the metric information about that application. If your application is like a batch job or something that runs periodically via cron, and there's what they call the push gateway. So your cron is running and it's pushing those metrics to a push gateway. So then Prometheus reaches out to the push gateway rather to your batch job, because your batch job might not be available, right? And then there are some services that do not support Prometheus out of the box. A good example is, for example, Postgres or Redis. So people write export, what they call exporters, where it hooks into the internals of Redis or Postgres and exposes Prometheus metrics around that. So for example, for the Postgres exporter, it uses the pgstat statements, looks into that internal and expose some information like how often an index is used, how many queries are running, and so on and so forth. So as I said, you can write targets by hand, but what we most commonly use, what most people end up using is service discovery, just because it is mostly used in Kubernetes land or cloud native deployments. So if there's a lot of churn on infrastructure, IP changes, targets change all the time. So you usually add service discovery. Prometheus supports a lot of service discoveries out of the box. And the most common ones would be the Kubernetes service discovery. So you just say, hey, I want to scrape all the pods in a specific namespace. You configure that, and Prometheus will do its job and discover all the targets there. There's the Google one for when you're running on VMs, and EC2 for AWS. And then the TSDB. This is a custom-built TSDB from Prometheus. The cool thing about it is they made it its own client library if you want to. So you can technically store your own time series database programmatically as well. I don't think I've seen anyone use that before, but it is pretty cool. It is a local database, so there's no built-in replication or anything like that out of the box. And it's not something that the Prometheus community is interested in solving. So one good thing about the Prometheus community is it's a very focused community. So it has its goals and sticks to goals. It doesn't try to address everything under the sun. So from a scalability replication, they say that is the concern of other systems / tools. It's usually the tipping point / scalability point that you face when you run a large Prometheus server. It doesn't handle cardinality well, as mentioned, says everything is a column store. And if you want to read more about it, I find it a pretty cool technology, at least on how they store the data, how they store the series, how wall works, how they use snapshots, and yeah, it's pretty cool. At least for me, it's pretty cool technology. So these are some links you can read more about how the internals work on TSDB. Before I go to data types, do you have any questions around Prometheus so far? Cool. Okay. So, before we go into the data types, I actually wanted to give a little demo of Prometheus server running. So let me zoom in a little bit. So I have a simple Prometheus configuration file, um, which is just scraping itself. So I'm starting a Prometheus server, and it's actually scraping itself. So if we look at how I'm starting the Prometheus server, it's just using a Docker container and exposing it on port 9090. So if I do up to the sage and go to localhost port 9090, I will see the from Prometheus UI, which is what we showed in the architecture here, a Prometheus Web UI. And I can scrape, I can query anything about it. So I'm going to get the build information, and you can see here the labels on this specific metric. And to show this a bit more, if we go to metrics, Prometheus exposes its own metrics. And if we search for build info, we have the help text, the type, which we'll go into a bit more detail, and then the metric itself. So we can see here it's just a text file that it's being parsed. This format is called the exposition format, just for you to Google. And this format is actually also used for what you might hear in the future, OpenTelemetry, because OpenTelemetry is a pretty hot topic in the observability world, and OpenTelemetry adopted the exposition format with some modifications. So yeah, that's just a simple Prometheus server running over there. So data types. Prometheus metrics are very simplistic. There's only 4 data types. Really, most people end up using 3. Summary are not used at all, are not used often, and at GitLab we don't even use them at all. So, starting with the most common one is counters. Counters are monotonically increasing counter values, so they always increase, never decrease. And you usually do this to observe, for example, hey, you got a cache hit or a cache miss, you increment that by 1, or increment it by how many often you want. You can increase it by 20, for example. And when you restart the application, they start from 0 again. As you can see here in the graph below. So this is a specific metric that GitLab exposes. You can see it's always going up, and then there's a deployment, it goes down and starts again. On their own, they're not really useful just because it's always going up, so you can't really read much from the data. And that's when you usually use a rate or an increase on that function, on that metric. So rate is a function. We'll go into a bit more detail into rates, into functions, sorry. But I wanted to show this on how counters are useful. So here you can look at the rate, meaning on a per second view, the increase of cache hits or the decrease of cache hits. For example, you usually provide a time range. With Grafana, you don't have to think much about this. You just do rate interval, and it calculates the per second increase. So the rate interval, how is this calculated? So it looks at a specific time range window. So for example, here we're looking at a 1-minute window. It looks at the counter value in that window and does a scatter plot basically between the data points and figures out if there's an increase or a decrease and so on and so forth. For the rate function to work properly, it needs at least 3 data points, but usually they do it up to 4 data points, just so you have a higher probability. And that's why sometimes you see 1 minute window, because if we're scraping every 15 seconds, there should be 4 data points in a 1 minute window. But sometimes if you scrape the target last, let's say 30 seconds, you usually do it a 5 minute window and so on and so forth. So remember, when you're doing the rate interval, the rate function, the interval needs to have at least 4 data points to create the lines properly. This is some more information on how counters work. Going into more detail, probably a better explanation than I did on around the rate function, the difference between multiple rate functions. So I mentioned rate and increase, and there's also irate. All of them have their own intricacies. The most commonly used one is rate, because increase only looks at increases. And the rate function also takes into account counter resets. So here you see it go from 15 million to 0 because of a deployment. The rate function automatically adjusts this, ignoring the 0, and still looks at the delta, basically. So the next one is gauge. Gauge is the most simplistic one. There's nothing to it. You increment it or decrement it. A common use case is, for example, how many memory your container is using or how many in-flights requests you have. It's the most simplistic one you can do. So there's not much to say about that. And then the quote unquote most complex one is histograms. So a histogram is a way where you can put your observations into buckets. The most common one is latency, request latency. So how long your request took. Usually create a subset of buckets, for example, 100 milliseconds, 500 milliseconds, and then you increment that bucket depending on the request duration. And the histogram is made up of 3 metrics. So the bucket and has a label less than. You can have multiple buckets, so you can have 5 buckets, 10 buckets, 20 buckets. But as I said, the more buckets you have, the higher the latency is, the higher the cardinality is, the worse the Prometheus server is going to perform. You have a sum, which is basically a total of latency and the count, how many requests you got, for example. So these buckets is something that you predefine in the application yourself. So most backend engineers end up saying, oh, which bucket am I going to use? Or like, for example, is it 30 seconds, 15 seconds, and so on and so forth. And this is something that's really exciting in the Prometheus community. They used to be called sparse histogram, but now they're called native histograms, where basically you don't define buckets anymore. But Prometheus handles that automatically for you. And the good thing about this is because you won't lose the resolution, right? Because if you do a bucket between 15 seconds and 30 seconds, you don't know if that request actually took 20 seconds or how many requests are taking 20 seconds versus 29 seconds, right? So native histograms solve that and solve the cardinality problem. So this is how a histogram metric looks like. So for example, taking a look at the Prometheus metrics it exposes, it has a bucket for the /metrics endpoint, and you can see all requests. I sent 60 requests in total, and all requests were under 100 milliseconds. You can see here that all of them got incremented to 60, and that's because Prometheus will increment each bucket that falls under that meaning. So if my request took 90 milliseconds, it will increment all of these because it took less than infinity, it took less than 120 seconds, and so on and so forth. What our histograms are mostly useful for is percentiles. So you might have heard, like, you never use averages, you use percentiles, because averages hide the long tail latencies and so on. So percentiles is what they're mostly used for. And we actually use histograms and percentiles for GitLab.com to define our SLOs sometimes, because histograms are really expensive from a data uh, storage perspective. And when at GitLab.com scale, sometimes we had to remove histograms and use something differently, just because of the cardinality. And here we can see an example of a query looking at the gRPC handling for Gitly, the P99. So for example, we see a spike here that took 8 seconds for one of the endpoints, for example. I skipped summary here. Summary is basically similar to histogram, but you do it on a percentile and you do it on the client level, not on the server side. And summaries are extremely expensive to compute. That's why most people end up doing it on the server side with histograms, because the application would have to compute the quantile. And that's why most people don't end up using summaries, because it degrades the application performance, which when we want to observe the application, we don't want to make it worse. Hopefully, we want to make it better. Any questions so far around the data types? Cool. So let's dig into a little bit in PromQL. So you see, one of the basic ones is selectors in PromQL. This means you can do thinking about translating from Postgres. This is how you do where clauses in PromQL. So you define the specific metric that you want, and you want to filter for a specific label. So you want to look at the hit for this cache metric, right? You can do not equal to, so like this. And then you can also do regex matching as well. So you want to look at hit and miss, or you don't want to look at hit and miss. So that's how you do selectors. You can define multiple ones. So for example, you can define exported type, and if this provides another value, for example, the Gitly instance, you want to filter for a specific Gitly instance, you do that. And then you can do certain operators. So some of the most common ones I showed here, there's a bunch of them, but these are the three common ones I've seen used mostly, is the arithmetic operator. So for example, here you're translating bytes into gigabytes because you're dividing by 1024 for 3 times. You can do comparison. So for example, this is a metric that shows if Chef failed on a specific server, so I want to look at all the failures that happened in production, so I do greater than 1. Technically, I should have done greater or equal than 1, because it only is a 0 or 1. And then you can do aggregation, basically summing by a specific label. So here, I'm looking at the cache hit, at the cat file cache total, and I'm summing by exported type. So I'm summing by if it's a hit or a miss fleet-wide. So it's not just by a specific instance, it's for all the instances. So you can do sum by, you can do average by, max, top, for example, give me the top uh, um, servers that have the highest hit ratio, for example, and so on and so forth. And then you can do functions. These are the functions we've already seen. The histogram, where you specify, give me like the P90 for this specific bucket. Give me the rate for a specific counter. And for example, you can give me a time. So if you have, like, for example, a cron job, like for example, at GitLab.com, we use Chef, and Chef runs every 30 minutes on the VMs. And here we can say, give me the current, like the time of the query evaluation, and subtract it with the timestamp for this specific runner manager, and it will show you when it actually runs. So you can say, oh, has Chef been running on this server or not, for example, or when was the last run? And there's, like, you might say, oh, why not look at logs? You can certainly look at logs, but when you want to try to aggregate to multiple servers or uh, um, on a time series, like look at the last 7 days, for example, metrics are a bit better around that rather than just looking at logs, just because you get a graph around out of it. If you want to learn more about queries, there's a bunch of resources around it. I'm more than happy to answer any questions here as well if you have any queries. But I wanted to do some demo for at least for our metrics. So our metrics are mostly accessible through, let me go directly into the homepage. Sorry. If we go to dashboards.gitlab.net and open up the Explore page and make sure we have Mimir GitLab gprod. So we want to query production. We can see that if we start typing, so I don't know if you're curious about Zuct, you can see, oh, we have Zuct version here. And if we run query, let me zoom in a little bit. I can see these are all the versions that we have. And the version I'm assuming is going to be a label. So control revision hash is one of the versions. So if I want to see how many versions we're running, we can do some by, for example, controller revision hash and see, no, some by, sorry. There we go. So we're summing by a specific label for this metric, and we can see here that there's only one version deployed, and we have 46 of the pods. If we look probably at the last 24 hours, there might have been a different version if we've done a deployment. Doesn't seem like it. Let's look at the last 7 days, maybe. Yeah, we see 3 versions were deployed on Zuct, for example, right? So it might be also useful for you to understand well, when things happen and so on and so forth, right? So this is just a specific metric, but let's look at counters, for example. So cache file, cat file cache total. If we just like execute this, Grafana will tell us, hey, this is a counter. Probably you should use rate. So let's add the rate. And here it added the interval. As I said, this is just a Grafana specific syntax. You can actually just say 1 minute. I want this run for the last hour, rather 7 days, because that's a bit much. And here it gives me all the Gitly servers that we have. But let's say we want to filter for this specific instance. We can just add the label. So the FQDN as a label. So I want to filter just for that specific instance, and that will give me the hit ratio and the hit, dirty, duplicate, and miss. And let's say I don't care about miss, so I do exported type equals miss, and it will give me the miss ratio. And you can see here, it's between 40 to 30 requests per second, or not requests like gRPC requests, but 30 misses per second or so. Any questions so far around PromptQL? Okay. I'm either doing a very good job or I'm doing a terrible job at explaining things. So I'll find out. So for GitLab.com, as I hinted earlier, Prometheus works really well, but it works well on a single server. For GitLab.com, we can't just use a single server because the TSDP can only handle so much data. With something that I didn't mention in the DSDP, it usually has a short retention policy. So usually store metric data for 2 days or 3 days before it gets too large to manage. And we wanted to have long data storage retention. And for example, we wanted to store 1 year's worth of data for forecast reasons, because we use these metrics for capacity planning to see if we're running out of headroom on the database or running out of headroom on Kubernetes or whatever. Um, uh, we didn't want a single server, because if one Prometheus server goes down, we lose all of the observability. So we wanted multiple Prometheus servers. We have multiple environments like production and staging. There's also Runway now, all the AI stuff. So all of them run in different GCP projects, and there was a lot of segregation. So, and we needed a global view for everything. So this is where um, we changed a little bit. The Prometheus community changed the opinion a little bit around 2, 3 years ago. So here, if we look at up here, this is what we saw in the main architecture, right? You have the Prometheus server with a disk attached to it. It's scraping the applications, it's storing everything in the Prometheus server, and you hit it with PromQL and sends requests to Alert Manager. What they changed around 2 years ago, I think, as they introduced the Prometheus agent, which is basically a trimmed down version of Prometheus, where it doesn't have the TSDB, but it uses remote, what they call remote write. So it writes the metrics to a remote server. So it could be another Prometheus server if you want it to be. There's a tool called Cortex. It could be a SaaS offering like GCP or whatnot. It could be Tenos. So basically, the Prometheus agent still scrapes the application. You still have service discovery, but instead of writing it locally, you write it to a remote storage. So you get higher availability out of that. And our choice before, it was Stanos, but now we recently changed it. By recently, I mean 3 to 4 months ago, changed it to Mimir, which was a long-term storage solution and a scalable solution by Grafana. It's there to extend Prometheus, not replace it. So it's there to be the remote write thing. Storage layer provides cheap long-term storage because it uses Google Cloud Storage. For us, it uses Google Cloud Storage, object storage, basically. So you don't need to run any Cassandra cluster or any large Postgres cluster or whatnot. It's just object storage, and you're reading and writing from it. It uses the remote write API with Prometheus. It supports multi-tenancy. So, for example, let's say we want metrics for the AI gateway to only be accessible to the folks in the AI team. We can do that. It has two scaling knobs, so it's pretty simplistic from a scaling point of view. You either scale up the read part or scale up the write part, depending on what bottlenecks you're hitting. And with remote write, we get the possibility of having the remote write endpoint publicly available. So if you spin up a new service, you just point your metrics to a specific endpoint, and your metrics are written to our global storage. So this makes it, even setting up new services, pretty simple, because before we used to have to set up a Prometheus server for you, or figure out how to combine the two Prometheus servers, or set up VPC peering or internal communication between Prometheus servers. So this made the setup a lot simpler for us. And this is a high overview of Mimir. So Mimir, you can run it in two main modes. One of them is the monolithic mode, which is basically just running everything in a single binary in a single process, or you can run it in the microservice mode, which is what we do here at GitLab, just for scalability, because then we can tune certain things. So here, the green arrows are the read path, and the red arrows are the write path. So the write path is pretty simple. You have the ingress, which it means a remote write. It's proxied by Nginx, and then if it's a write request, it goes through the distributor, which handles sharding of the data and so on and so forth. The ingester, which caches the data on disk, and at some point it stores to cloud storage. By some point, I mean if it reaches a specific size limit or if it reaches the block size, which is every 2 hours, or a block retention window, sorry, which is every 2 hours or so. And then the reader here, we have the query front end, which is basically the same as the querier, but it's just a caching layer in front. You have the query scheduler, because the good thing about Mimir is you can shard your queries. So for example, some of the queries you saw me request weren't handled by a single server, but they were handled by 15 different servers, where they got a piece of data, each of them, and then the querier combined everything. You have the storage gateway for chunk and metadata, and then we have the ruler and alert manager, which is what sends our alerts. Some of the exporters we use at GitLab is, as I mentioned, the Postgres exporter, because Postgres does not support Prometheus out of the box. Cloudflare exporter, Redis, for the same reason. Process exporter, which gives us some nice information about processes that are running on Linux. So for example, one thing that we're really interested in is how, back when we were on VMs at least, is how the Ruby Puma workers were running. Or for example, we use the process exporter for Gitly to see how many Git processes are running, how long those processes are running, and it gives us all that information, what commands are actually run. CAdvisor, which gives us all the information around containers. The black box exporter, which is pretty nice. This is simply just an exporter that sends a request to a specific endpoint. It reports success or failure if it's 200 or not 200. So we use the black box exporter as the first line of defense to see if the website is available or not. This is like a self-hosted version of Pingdom, if you're familiar with that, or anything like any service that pings your website to see if it's up or down. And then we have the node exporter, which exposes all the internal Linux information around a specific VM, around CPU usage, memory usage, how many file descriptors you have open, you name it, disk latency, and so on and so forth. Yeah, that's it. Thank you. And if you want to learn more around it, I gave you some links here. The Prometheus docs feels like a cheap shot just linking to the Prometheus docs, but they are one of the best technical documents I ever read. And most of the information you need is in these documents, and they're pretty comprehensible. So if you need to learn more about Prometheus, I would start with this, just because they're really one of the best documents I've ever seen compared to other documentation. So that's it. Yeah. So I'll open it up to any questions anyone has. We have, I think, 20 minutes left, 10 minutes left for a question. So yeah.
You mentioned that you store a year's worth of data. How often do you go back and actually do back analysis?
I would say like for me, I would do it pretty often. Like not year plus, but maybe multi-months. Mostly because you want to look at trend of the data and things like that. And we actually use the year data quite often for Tamland. So we have, let's try and find that. We have capacity planning. What uses capacity planning is Tamland. Oh, I picked the wrong one. Let's see. Let's see this one. So Tamland report. This looks at a year worth of data. Probably we just don't have enough data for this one, but it looks at capacity planning, looks at the trend, see if it's gonna reach saturation. We have specific SLOs around that. And yeah, we do trend forecasting with that, and it saved our bot multiple times, like with Redis saturation, database Postgres CPU saturation. even run our saturation. So like we use this on a daily basis. So I would say it's still pretty useful. We downsample some of those datas. I don't have the uh, timelines by by heart, but like at a specific time. So for example, after a month, we downsample the per second per second metrics to every minute, for example, because you don't need that granularity 1 month plus, right? So we downsample some of those metrics to save up on costs and storage.
Cool. Thank you.
Hey, Steve, do you know anything about uh, the Cloudflare exporter that we run? I didn't
Oh
know we had
gosh.
this, and I just saw it, and I thought, this could be useful for our team actually, because we were just looking
Yeah,
at Cloudflare
it is.
notifications.
It is a pretty horrific story, to be honest. It's an unmaintained
Oh,
exporter. Um,
mm,
so historically speaking, first we had our own Cloudflare exporter. I can't remember the name. I think it's GitLab.com Cloudflare exporter. Let's see if it's still there. No, no. Let me see.
all
No.
capitals typo in there.
But oh, yeah, there is a typo. Yes. We had our own exporter.
I think I looked at this before. Isn't the problem that they basically you need to call a GraphQL API to pull these metrics first, and then
Yes,
import them
exactly.
wherever you need?
That's
Mm,
the hardest part around writing Cloudflare export for the exporter for Cloudflare, because you need to hit the GraphQL API.
mm,
Then you need to attach a timestamp for each metric that you publish. Then you need like since you send a request to GraphQL every X seconds, and Prometheus hits you every X seconds, you need to store multiple values, multiple vectors, basically. Um, so for
But where
like
is this
for
running? Like, so where does the Cloudflare exporter run that then actually
it runs
generates?
in a Kubernetes cluster for us. We
Okay.
deployed this one, the Cloudflare exporter. So if we go GitLab.com, GL infra, Gates workloads, file files. I really hope this not did not change on me, but let's see. We see Cloudflare exporter. We
Okay.
deploy it on Kubernetes, and
Okay, but if we
the,
already run it, it shouldn't be like, I mean, if we use it, I don't want to
yeah,
hijack the
we use it.
discussion, but
It's
that's
just
interesting to
it's
know.
not very well maintained in the sense like
Okay.
it's an open source. Like it's not maintained by Cloudflare itself. Cloudflare just suggests
Mm-hmm.
you to use this one, and historically it hasn't been um, the best. Maintained application. So you see, like for example, I don't think even it has worker metr. Oh, it has worker metrics. I was wrong. But some metrics are missing sometimes. Like if it's a new feature,
Mm-hmm.
it usually takes a while for this to get through. But we do have a dashboard around it. So if we look at uh, Cloudflare, I think we did have a dashboard. So Cloudflare overview, we're gonna see the requests per second, but like it's not the best, I think, exporter in the world, simply because as
Mm-hmm.
you said, like uh we have to send requests to the GraphQL API and then store those responses multiple times depending on the timestamp, and then Prometheus will reach out to it at a specific time. So um, this is what we use.
Okay.
It helped us, but we probably will need to extend this a little bit more in the future, especially for um, cells. With cells, we're using Cloudflare workers, and we'll probably need more metrics around that on how much CPU we're using and so on and so forth. And that's probably not exposed
Okay.
through the exporter. So that's some work to be done from our side.
All right. Thank you.
Any other questions? I guess that's the amount of awkward silence I can handle. Thank you so much, everyone. Have a nice day, and see you.
Thank you. This was great. Thank you, Steve. Bye.